Crazy Hat Chemist. So another video here on gases number 3. Let's get moving. Bam! So today we're talking about the kinetic molecular theory, or KMT for short. So you have some postulates to the kinetic molecular theory. Here's the first one. Number 1, gases consist of tiny submicroscopic particles. That means that I cannot see the gas molecules. They're submicroscopic. Okay? All right, the volume is open space compared to the volume of a gas molecules themselves. Okay, hopefully you got that. The volume is empty, open space compared to the volume of the gas molecules themselves. Particles have no attraction or repulsion forces for one another. That means that gas molecules are floating around here and they don't attract each other, they don't repulse each other. Okay, particles move in a constant, random, rapid motion in straight lines, colliding frequently with other gas molecules and the sides of the container. That collision of the sides of the container gives rise to the pressure of the container. So gas molecules move in a straight line, they hit the container. As they hit the container more frequently, then you have greater pressure. Okay, the collisions are 100% elastic. Essentially, that means if I were to take this object here, drop it on the floor, it would bounce right back up to this same level. That means that no energy is lost in a completely elastic collision. Okay? The average kinetic energy is directly proportional to the Kelvin temperature. So what that means is that as you increase the temperature, then the kinetic energy goes up. I.e., as the kinetic energy goes up, as the molecules move faster, then the temperature is increasing. So if you increase the temperature of gas molecules, then they will be moving faster and faster. Okay? There are no ideal gases, and these set 1, 2, 3, 4, 5, and 6 corollaries here let you know what an ideal gas is. So if an ideal gas follows all these parts here, if a gas follows all of these, then it is an ideal gas, but there are no ideal gases. That is, gases do have a volume, okay? The collisions are not 100% elastic, okay? And they do interact with other gas molecules. There is an energy loss as well. So not all of these are true, but in order to make the kinetic molecular theory work, okay, these are the assumptions of the kinetic molecular theory. It allows us to do the math on these problems nice and easy. All right, so a little bit more about the kinetic molecular theory, and what is actually really important about this is Maxwell's equation. So here is Maxwell's equation. RMS stands for root mean square. Okay, and where the U is the speed. The bar over it tells you that it is the average speed, and it is the squared of that average speed. It's the root of it, meaning it's the square root. Okay, the M is for the molar mass. The 3 is just a numeric value of 3. R is the gas constant. That's 8.314510 joules per Kelvin moles. And the temperature, of course, is in Kelvin, as everything for this entire unit is in Kelvin. So what does this equation really state, first of all? Okay, the lower the molar mass, the faster the gas. And you can see that with this graphic here as well. You can see that as the density increases of that gas, as the gas molecules are heavier, then they're moving slower. So, for example, hydrogen gas is very low in mass, low in density, and at the same temperature compared to other gases at the same temperature. The hydrogen gas is moving much faster than, let's say, any other gas because it is the lightest, least massive gas. So if I were to compare hydrogen gas compared to carbon dioxide gas at the same temperature, okay, carbon dioxide gas, since it is much heavier, more dense, it will move much slower. That's what that means. That's what that equation will give us. All right? Hopefully that makes sense for you. Okay, and I got a great hat here for you. I got this here, and then all my favorite students who are cheerleaders signed this, and they went over to Disneyland just to get me this hat and buy me this hat. Thank you very much. There was a whole group of them. Give me a thumbs up if you like that video. Subscribe to my YouTube channel, and I'm going to see you next time for more gas. I feel like some's coming on right now. Oh.